All right, guys, it's time for the final hurdle before we get to our goalpost. In this lesson, I want you to switch over to the final hurdle challenge, which is hurdle 4. And in this particular version of the hurdle, the wall that the robot has to jump over to now has a variable height. So the height of each of these hurdles is completely random, the position of the hurdles are random, and also the number of hurdles is also going to be random. You can see that every single time that this regenerates, it comes up with a completely different set of hurdle profiles. And now we can't just jump because we don't know what the height will be each time. So we have to use what we've learned about while loops to modify this jump function and see if we can get the jump to jump as high as necessary depending on the height of these walls. Just as a reminder, in order to complete this challenge, you should take a look at the Rebor's keyboard window and go to this tab called Conditions and see that you can check if the front of the robot is clear, if its right is clear, if there's a wall on the front, if there's a wall on the right, and various other things. The ones that are probably going to be the most useful is this top row here. So we want you to take a look at these conditions, see how they're spelt and how you can use them, and then try to use them and test them out using your Reborg robot. Now the goal is of course to reach this final flag, going over various hurdles using this dotted line as the path, which is going to be different each time. Just as a head up, this is going to require you to modify this jump function, have a serious think about it because it's not easy, and you're going to need to use more while loops to achieve this and outcome, and try to see if you can solve this challenge in the least lines of code possible. So I managed to do it in as little as 24 lines of code, so see if you can aim to achieve that. Pause the video now and give this challenge a go. All right, so the key difference between this particular hurdle and the previous version is that the height of the wall is now random. Instead of just jumping over one square where we turn left, move, turn right, move, we have to now see if the right side has a wall or if it's completely clear. Now, in this case, what I want to happen is I want to turn my robot to the left first of all, and then I want to check if there is a wall on the right. So I can use this condition, wall on right, to achieve this. And if that is true, then I want to continue moving forwards until there is no longer a wall on the right, in which case I'm going to turn right, and then start going down. So let's modify this jump function. We definitely need the robot to turn left, but after it turns left, we're going to use a while loop to say that while there is a wall on the right, then in this case, we're going to move forwards. So we're going to go up in this direction basically because we've turned left already. Let's test this out and let's run this code. You can see in this version of events, my robot is going to keep going until the very end of the screen. This is not what we want. So what we want to do is when this is no longer true, it's going to skip to line 10. So at this point, there is no longer a wall on the right, because otherwise it would have continued looping and calling this line 9 where it gets it to move forwards. When there's no longer a wall on the right, then we want to do what we did previously, which is to get our robot to turn right, move, and then turn right. Now at this point, we have to move down the wall, and what we're going to check is whether if the front is clear, because it's only when we reach the very bottom here, when the front is blocked, do we actually turn left again and continue back to our while loop here to move forwards. To do this, we're going to add yet another while loop. And in this case, we're going to use the front is clear condition. While the front is clear, we're going to get the robot to continue moving forwards. So once it's turned to face this direction and there's no wall in front, it's going to keep going until this is no longer true. And that is the end of our jump. So now we've basically modified this jump function to take into account all of these new things, such as while there's a wall on the right, then continue moving upwards. While the front is clear, when it's coming down, then continue moving downwards. And then at the very end, we're going to get our robot to turn left, so that we're ready to go and check if we're at the goal. And if we're not at the goal, then we're going to check if there's a wall in front. If there is a wall in front, then we're going to jump. Otherwise, we're going to continue moving forwards, or rather to the right, to get to the goal. So now this is the final code. And depending on the number of spaces you've added in here, obviously it's a little bit easier to read if you actually have it like this. But depending on how you've spaced things out in your code, you should end up with anywhere between, say, 20 to 24 lines of code. So I want you to be able to see all of these lines of code on the right when we run this code. And I've actually got a typo in here that it's going to tell me. So it's going to say invalid syntax, and the problem is just because I forgot a colon here. If you get that pop-up invalid syntax, be sure to check if you have any problems in here. And it can get a little bit complicated if you leave your code for a long period of time before you test it. So test your code after every little iteration, and then when you actually get something like an invalid syntax, you'll be able to catch it more easily. So now let's go ahead and regenerate our map, and let's try again. So when we're going to make a jump, and then we're going to turn right, and we're going to keep going down until we hit the wall, where we turn left. And now we're not at the goal, and there's still a wall in front, so we make another jump, and we go down this much, much larger wall. And then we continue this process of using several while loops, checking if there's a wall on the right, checking if the front is clear, checking if there's a wall in the front, in order to achieve our goal and get to our final destination. Now, for your code to successfully complete this challenge, the line that your robot draws should follow the line that's dotted here, just like what you see here. So instead of going just over the top and getting to the final goal, it should follow each of these steps, and finally you should get that green pop-up where it says it's at the right position. So did you manage to complete this challenge? If not, be sure to review the lesson on while loops and just have a play around with while loops. Try some of the different conditions and see what happens when you run the code, and see how the robot behaves, so that you get a good grasp of how these things actually work. Now, on the next lesson is our final project, and we're going to get our robot to be able to navigate a maze all by itself using what we've learned, including functions as well as while loops, as well as using good indentation. So for all of that and more, I'll see you on the next lesson. All right, guys, it's time for the final project of today. And the goal is to be able to write some code here in Reborg's world to be able to get our little robot to be able to navigate to the goal and go through a maze no matter what the maze looks like. So if you go back to Reborg's world, if you already got a link open, if you don't, then simply click on the direct link in the course resources and it should take you here. And we've got the maze selected in the drop down, which is right here. Here we have a maze. And even though the maze doesn't change, the robot does. The direction that the robot is going to face is completely random. The position of the robot is also random. So you can see every time I restart the game, it will face a different direction. So in this case, it's facing up, but the next time it might be facing down in this case. And it's also always going to start at a random location in the maze. If you click on the world info, it'll tell you that the secret to getting the robot to complete the maze is to get it to follow along the right edge of the maze. If it starts anywhere in the maze and it just continue following along the right wall, it should eventually get to the final destination. For example, like this. Now, in this case, the robot is not making a beeline straight to the exit as if it could see what we can see, but it is following a strategy. or rather what you would call in programming an algorithm. And the algorithm here is to simply follow along the right edge of the wall, and if the right side is clear, then continue going right until it's no longer clear, at which point it should just go straight. And if you can't go straight and you can't go right, then the last option is to turn left. It's almost like the robot is getting a set of instructions in terms of hierarchy. The most important, telling it to turn right if it can. If it can't turn right, then go straight ahead. And finally, if it can't turn right or go straight ahead, then to turn left as a last resort. So you're going to need to use a lot of the functions that you saw previously, such as move, turn left, and testing whether if the front is clear or the right is clear, or there's a wall in the front or a wall in the right, and whether if the robot is at the goal. Think about how you can use a while loop and also the conditional if, elif, else statements to achieve this goal and get our robot to be able to go to the final destination no matter where it starts out and what direction it's facing. Pause the video now and try to use what you've learned to complete this final project. Alright, so did you manage to complete this challenge? If not, let's work through the solution together. The first thing we need to do, which we've always pretty much needed completing each of these challenges, is we need a way to turn right. So I'm not going to type it all out again. This should be already pretty clear. Turn right is just turning left 3 times. Now, the next thing we need to do is we need to tell the robot to do things and to check for things until it reaches the goal. We know that we have this test called at goal, so we can use a while loop to get the robot to continue working until it reaches the goal. To define that, we could say while not at goal. So basically keep repeating the instructions inside this while loop until at goal becomes true and not true is false. So once this condition becomes false, then our while loop stops. So what we were told in the world info is we should follow along the right edge. We should test to see if the right side is clear, and if it is, then we should turn right and go straight. So that basically means moving right. Let's use an if statement to test if right is clear. And in this instance, so in this if block, we're going to say, well, turn right using our pre-built function up here. And then once you're facing the right, then move forwards. This should achieve a right move. So from here to here, for example. Now let's test this and see what happens. In this case, the right is clear, so it moved right. The right is not clear, so it doesn't know what else to do, and it's now stuck in what we would call an infinite loop. And it will never stop until the browser actually forces it to by crashing. So what we have to do instead is we have to provide an alternative condition. When the right is not clear, what should it do? So we're going to provide that condition by using an elif statement. And what we want to say is, if the right is not clear, well then maybe you should check if the front is clear. And if that is the case, then simply just move forwards. Now, this would work unless we're in the situation that we're in right now, where we're boxed in and the only side that's clear is actually the remaining one, which is the left. That's why we have to put in the last line of code, which is going to be an else statement. So in all other conditions, when the right is not clear and the front is not clear, so once both of these have been checked and they're false, then actually just turn left. So now you can see that when our robot is able to go right, it will try to follow along the right wall, but when it can't go right, it'll go forwards instead. And when it can't go right or go forwards, then it's going to turn left, and hopefully the next time it checks the loop, the front will be clear and it will be able to move forwards. So notice how our robot is somewhat haphazardly navigating through this maze, but it is following the algorithm that we specified, which is to follow along the right-handed wall until you reach the goal. And that's what these few lines of code does, using our while statements, our if, elif, else statements, and also our turn right function. There you have it. You've now completed day 6. So congratulations on getting this far, and I'll see you tomorrow bright and early.
Hey, well done for completing day 6. Now, I remember back when I was learning how to windsurf, just how hard learning a new skill can be. And I think when you become an adult, this is like a really unfamiliar sensation, learning something new. Because more often than not, you're probably working in a job that you've done for years, you've probably gotten really good at it, and you haven't actually needed to struggle to really feel the pain that you feel with learning. And this might be the first time you're doing that for a while. So just as when you get onto a windsurf board and you hit the water a few times really painfully, I just hit my face so many times that you feel like this is too hard. But actually, the struggle is necessary. The more you struggle, the more you're learning. So don't interpret the struggle as a bad thing. It's a good thing. It means that you're making progress. So keep going, and I'll keep practicing my hat tricks.